Okay, so when I recorded this tutorial, I did not have the mic plugged into the correct machine, so I'm going to try to do a voiceover, and I don't know how well it's going to go. I've never done a voiceover before. But so this is a tutorial on using a couple of Python scripts in SAMSON to make some hexagons and then to carve those hexagons using an STL object. And I don't know what I would have been saying here. But if you go to samsonconnect.net/Tom Moore, you can get the file that we're working with now. You can download it, carving hexagon tutorial. So this is what I'm showing. And then we'll go back. And so then I'm saying I'm introducing the scripts. There's a build hexagon script, a carve STL, and then I'm showing the STL object. So I just created this in Blender, but you could use Blender or any CAD program to create basically any type of STL object and open it in SAMSON. And we're going to use that later on. And then we're going to go to our hexagon script and we're going to right click on it and go to file, and we can go to edit, and that's going to bring up this little code editor in SAMSON. And this is a script that I wrote, and so it basically produces hexagons of Lonsdaleite, and it's pretty easy to use. You really just have to set two variables: the number of rings along the side edge, the outer side edge, and then the number of rings along the diameter of the hexagon. So this is what I'm setting here. Then we can go ahead and hit the play button and run it, and it makes a little hexagon. And then we're going to click the structural model and add our covalent bonds. And so this script only creates 3 layers of your hexagon, but then we're going to use SAMSON's linear pattern editors to basically extrude this to whatever size we want. So that's what I'm going to be demonstrating here. So we'll click the linear pattern editor. And once we do, SAMSON will create these number of copies for us. Currently I have it set to 12. And I don't want 12, so we're going to decrease the instances. And then remember, the way that this works is basically you're going to match overlapping atoms, and then that's where your fuse operation is going to happen. And I think in the original audio, my dog was barking in the background because something was happening, and then I get all all flustered. So it's for the best that maybe I'm re-recording this. But yeah, so here I am getting the atoms to overlap and checking it out. This is actually easier because it's less. You don't have to. You can just talk and not have to do the actions and talk. So then we'll go ahead and confirm this, and it will create the hexagonal chunk like so. And now we're going to carve it with this STL object. Now I did not write the STL script. That was provided by 1Angstrom. Those guys have always been really supportive and great in helping users to get the tools that they need to be productive. So basically, what I'm showing is, if you're how to align your STL object. So maybe it's not perfectly aligned when you import it into SAMSON, but you can use the align functions to do that, to get it centered up however you like. So I don't want it to go all the way through. I think we're just going to create a little hexagonal pocket, and here we go. We're going to take a look at the carve script, but there's really nothing to set in the carve script, but we're going to open it anyway, I think. just going to show we're going to carve this into like the way it works is it basically creates two groups. It creates a group of atoms inside the STL object and a set of atoms outside the STL object. So it doesn't, it basically groups, it doesn't carve, but to carve it you basically delete one group, and that's what I'm going to show here. So we'll hide the hexagon and we'll show the all the atoms outside of it, and then you have all the atoms inside it, which we're going to delete, and that's why I'm calling this a carve tutorial. So we'll select those nodes, hit delete. Now we have a little perfect little hexagonal pocket and a perfect little hexagonal workpiece. And then always, because of my Lon's Delight hexagon script, the dimensions are slightly off. I haven't quite fixed it yet. Maybe I will by the time you're watching this, but it's always a great idea to just go ahead and minimize your parts anyway. SAMSON has a really great minimizer, and so that's what we're doing here. And I think I just let this play out. Yep. Okay, and that's our tutorial. Thank you.